This is going to be a rather lengthy set of notes over compound inequalities. It's going to be lengthy because there's a variety of kinds of problems that you have to confront when you're considering compound inequalities. So let's go ahead and jump right in. Hopefully you'll pause for just a minute to set up your notes page just like mine. We'll start with our first example here. So I've got 5b minus 7 is greater than or equal to 13, and 2b minus 5 is less than or equal to negative 1. Okay, so 5b minus 7 is greater than or equal to 13, and 2b minus 5 is less than or equal to negative 1. The first thing I'm going to do is solve each of these separately by undoing, which is a skill that we developed last semester. And so I'm going to start with minus 7. I'm going to do plus 7, which is the opposite. I have to do it to both sides of the inequality. So I'll do 5b, because these cancel out, is greater than or equal to 17 plus 3. Sorry, 13 plus 7 is 20. Then I'll divide by 5. And so b is greater than or equal to 4. Okay, now I have to solve the second one, which I'll do in red here. So I'll add 5 to both sides. That gives me, because these cancel out, 2b is less than or equal to negative 1 plus 5 is 4. I'll divide by 2. And so b is less than or equal to 2. And now I have this word in between, and. Okay, so the first thing to know is that when you're considering the word and, it means that both things have to be true. I'll give you a verbal example here, which you can write down or not. I'm not going to write it down. If I gave you this as your job, I said, if you mow my lawn and till my garden, I'll pay you $40. The question is, how many things do you have to do to get paid? And the answer is 2. You have to do both things because I used the word and. And so I'm going to put parenthetically here, both are true. That's what and means. And so I think one of the easiest ways to think about this is to draw a number line. And so I'm going to put my cardinal numbers here, 2 and 4. And I'm going to graph each of these inequalities separately. So b is greater than or equal to 4. So I'm going to put a closed circle around 4. And then I'm going to shade to the right. Which I'll do my, there we go. So I shaded to the right. Okay, for b is less than or equal to 2, it's a closed circle here. And then less than or equal to is to the left. And so when I look at that, what I notice is that they don't overlap. And what that means is that since they don't overlap, they both can't be true. Think about it like this. b is greater than or equal to 4 and b is less than 2. So what we're saying is that since they don't overlap, there's no number that's both bigger than 4 and smaller than 2, which makes a heck of a lot of sense. So since they don't overlap, we're going to say no solution. Because they can't both be true at the same time, and the word and requires that they both be true. So I'll go ahead and click no solution here, and that's our first example. Let's look at the next one, if it ever loads. Okay, so our next example is going to have 3z is less than or equal to 18, or 8z minus 3 is less than or equal to 29. So 3z is less than or equal to 18, or 8z minus 3 is less than or equal to 29. So I'm going to divide by 3. I'm solving each of them separately. So z is less than or equal to 6. 8z minus 3, I add 3. 8z is less than or equal to 32. Divide by 8. So z is less than or equal to 4. Okay, and the word is or between them. Let's go back to our graph. And so I'll make this one red, and I'll make this one purple when I graph it. So I'll put my numbers here. I have 4 and 6. So I'm going to use this example again. So if I said to you, your job is the following. If you mow my lawn or till my garden, I'll pay you $40. Because I used the word or in that statement, it means you can do either thing. You can decide which one you want to use. And so or in mathematics means either is true. And that includes times when they're both true. So in my example, you could mow my lawn and till my garden, and you'd still get 40 bucks based on the deal that I laid out for you. Probably wouldn't think that was very fair though. So z is less than or equal to 6. I'm going to put a closed circle at 6. Less than or equal to is to the left, which I'll do with a shade. Okay, now I'll look at z is less than or equal to 4, so I'll put an open closed circle there because it could be equal to, and then again I'll shade to the left. Okay, and so when I look at this, either one can be true. And so it looks like all of my solutions are all the numbers that are smaller than 6. And so because either one can be true, you could have numbers that are less than 6, so 5 is an answer that works. Or you could have numbers that are less than 4, like 3 or 2 or 1. But because all of the numbers that are less than 6 already include the numbers that are less than 4, I can condense my answer. I can write it a little bit more quickly because my solution set is just the numbers that are less than or equal to 6. And that condensation occurs because we're using the word or. So I'll put this here, boom, and we like it. Let's see if we can do one more example here. All right, let's see how this one goes. So I have 6x minus 4 is greater than or equal to 20, and 2x is greater than or equal to 4. I would encourage you to pause here and give it a try, and then check your work against mine here. So 6x minus 4 is greater than or equal to 20. I'll add 4. 6x is greater than or equal to 24. Divide by 6. So x is greater than or equal to 4. Divide by 2. X is greater than or equal to 2. And so the link here is and. I'll do purple and red again. So I'm going to go ahead and draw my number line. So and means that they both have to be true. And so I'm going to put 2 and 4 here. First things first, I'm going to do x is greater than or equal to 4. So those are numbers that are here, closed circle, and to the right, because those are the numbers that are bigger than 4. So let's do x is greater than or equal to 2, closed circle, and I'm going to shade again to the right. And so we look for where they overlap, and they overlap over here. And so numbers like 3, which are between 2 and 4, don't work for this one because 3 is not both greater than 4 and greater than 2. So only numbers that are over here that are both bigger than 4 and bigger than 2 work. And so again, I can condense my description of what's going on here. X is greater than or equal to 4 is all I have to say, because those are the only numbers that are both. So again, I'll condense it down to 1, and there we go. Let's see if there's one more type of example here. There are a couple different kinds that you can sort of run into when you're doing these kinds of problems, and I'm willing to, of course, help you out with that stuff. But again, I'm going to ask you to see these notes before you get going. Let's go ahead and go back in and do the rest of these Cornell notes. So with Cornell notes, you have to take a breather and think about what's going on. And so for this first one, I'm going to say, how do you handle and? I can put how is it graphed here. Here I'll put how do you handle or. And this we can just call example 3. I'll leave this section down at the bottom. You need to write a summary of what you learned by doing these notes. so that you have the opportunity to lay down some memories. I would really suggest doing this before you try to engage the problems because I'm sure it will help out.